Hello everyone, welcome to the class on operation research where we are discussing the concept of assignment problem. And in today's class, we'll discuss the problem related to the assignment problem which came in the May 2016 exam. So the basic approach what we do to solve assignment problem, we solve assignment problem by using Hungarian approach. You explain Hungarian method for solving assignment problem. So that I did, right? Hungarian method, already I explained you how by using Hungarian method you can solve an assignment problem. So that part already I have done for the people. Now in this class I'll discuss the numerical which came related to this Hungarian approach. So you can read this question 21B. Please read this problem. So in this problem, it is given there's a departmental head. It has four subordinates. So like the 1, 2, 3, 4, and they have four tasks to perform. Those tasks are given to you A, B, C, D. The subordinate differs in the efficiency and the tasks differ in the intrinsic difficulty. These estimate of the time each man they what they did, they estimate the each time what each man will take to perform each task that is given to you. So how should the task be allocated one to a man so that to minimize the total man house? So you can understand this problem. This problem is all about assignment problem, how we can solve it by using Hungarian approach. So to solve this problem by Hungarian approach, we'll try to understand solving this problem. Before we solve the problem, few conditions what you know already, which I'm mentioning from last so many classes, that whenever we solve the Hungarian based problem, the objective function for Hungarian based problem is always minimization. Okay, so we can never solve the problem if the objective function is maximization. So whenever we are solving, it should be always minimization. You can also see here that they have written very clearly that how should the task be allocated one to a man as to minimize the total man hour. So the objective function is minimization. So we are clear with that. So we cannot solve assignment problem when the objective is maximization. We can do, but for that we need to do additional homework. The homework what we have done even in transportation problem also. Transportation problem also, you remember, right? We can find the initial basic feasible solution either by northwest corner method or either by Mughal approximation method or by matrix minima method. But in order to do that, first of all, the objective function should always be minimization. In case if it given maxima matrix, then we have to convert the maxima matrix into minima matrix by subtracting all the elements from the highest element. So that way we converted the maximum matrix into minimum matrix, and then we used to solve the problem. So here also the same logical approach we use, but we are lucky that in this problem that the objective function is minimization. So we are good to go. Next thing is that whenever we see the matrix, it should be a square matrix. Okay, for the assignment problem. In case if it's not a square matrix, if it is not a square matrix, we'll make it as a square matrix by adding dummy row or dummy column. So here it is square matrix. So again, that problem is not there. Now, only thing we need to do allocation of the assignments. So when we do allocation of tasks over the men, so here we need to understand that one man will do one task. One task will be done by one man, and we need to do that allocation in such a way that the overall the cost should be minimized. Okay, so if I just take the print screen of this question, put in my solving area. So let me just write down the problem. 18, 13, 38, 19, 26, 28, 19, 26, then 17, 14, 18, 24, then 11, then 26, then so yes, then 11, 26, then 15, and then 10. This is the matrix given us. This is the set of matrix which is given to us. Okay, so what we'll do, we'll work on solving this assignment problem by using Hungarian approach. So when we are trying to solve the problem by using Hungarian approach, we'll find first the minimum element in every row. The minimum element in every row, we'll find the minimum element in every row. Then this minimum element in every row, what we find, we'll subtract all the element of the row by that minimum element. This is what we do in Hungarian approach. So if you get theory question also, so you can do that. So you can create an artificial matrix, assuming that you can create artificial scenario. Suppose 4 tasks, 4 men, and the following are the costs associated with them. Find the minimum, do allocation in such a way that the total cost minimize. So let the matrix is like this. Okay, then identify the minimum element from each matrix. Okay, in each row, then subtract all the element of that row from that minimum element. All that you can do by yourself, right? So if you get a theory question also, you can do that. So the minimum element, so 18 minus 11, 7, 26 minus 11, 15, 17 minus 11, 6, 11 minus 1, 11, 0. Clear? Then 13 minus 13, 0. 28 minus 13, that is 15. Okay. So then 14 minus 13, 1. 26 minus 13 is 13. Then 38 minus 18 is 20. 19 minus 18, 1. 18 minus 18, 0. Okay, sorry, here the minimum element was 15, guys. So not 18. So the minimum element here was 15. Yeah, so 38 minus 15, that was 23. 38 minus 15 was 23. Okay, 19 minus 15 is 4. Okay, then 18 minus 15 is 3, and 15 minus 15 is 0. Then 19 minus 10 is 9. 26 minus 10 is 16. 24 minus 10 is 14, and 10 minus 10 is 0. Once we do this work, once the row wise we have done this, now we'll do the same thing column wise. So the minimum element in this column is 0, here is 4, here is 1, here is 0. So identify the minimum element in each column. Okay, so write the theory. You can write the theory. Okay, you can write the theory if you want. I can write it here. Identify the minimum element from each row. Identify the minimum element from each row. Identify the minimum element from each row, and subtract and subtract and subtract all the element of the row. Subtract all the elements of the row, or subtract all the elements of the row from the minimal element, from the minimal element, from the minimal element. Got it, right? So once we done this work, then we'll do the same thing column wise also. So identify, hope you are getting it. Identify the minimal element from each column. Identify the minimal element from each column. Identify the minimal element from each column, and subtract all the element of the column. Subtract all the element of the column. Subtract all the elements of the subtract all the elements of column from the minimal element, from the minimal element, from the minimal element. Column wise, if you do column wise, you'll get 7, 0, 23, 9. Then this is 11, 11, 11, 11, 0, then 12, then 5, 0, 2, then 13, then this is 0, 13, 0, 0. Done, right, everyone? So now you have at least 1 0 in every row and every column. So according to Hungarian approach, the allocation, what we do allocation on looking at the 0, where we'll see first row wise, then column wise, that where is 1 0. So if a row has 1 0, we'll do allocation. So you can see here this row has 1 0. So I do allocation. So if this row has 1 0, so I'll do the allocation. This row has 1 0. Yeah, so if you see this row has 1 0, so you'll see the first row has 1 0, so I'll do allocation. If I do allocation, I'll cancel this and this. Second row has 2 0, don't touch it. Third row has 1 0, cancel. 1 0, don't touch it. Fourth row, and you can't do anything. First column, 1 0 is there, you can allocate. Cancel the other zeros if you have in the column. Then second column you have 1 0, you can do allocation. Then so if you notice, first row is allocated, second row is allocated, third row is allocated, but the fourth row you could not able to allocate. So if you are not able to allocate any row, then what you do, tick that row which is not allocated. Tick that row which is not allocated. In that row which is not allocated, see where zeros are there. Wherever zero is there, tick the corresponding column for the zero. Okay, now within that column, see where is the allocation. So wherever is the allocation, tick that corresponding row for that allocation. Then once you're done with this, now draw a line. Once you're done with this, what you can do, you can understand this is 0 0. So this is 0 0 cross. This 0 0. Now once this is done like this, now what you do, you cross this line, cross the column which is being ticked and cross the row which is unticked. Cross the column which is being ticked, cross the row which is unticked. Now out of all the elements which is not at all cross, find the element which is minimum. So out of all the elements which are not cross, you can see these are the elements which are not cross. So out of all the element which is not cross, find the smallest element. So all the element which are not cross, I put blue color marking over them. So you can find the minimum element. So that minimum element out of that is 5. So 5 is called theta. So 5 is called as theta. Now what we'll do, so all the elements which is not crossed, okay, subtract theta from them. So 7 minus 5, 2, 11 minus 5, 6, 5 minus 5, 0. Okay. Then third row, 9 minus 5, 4. Then 12 minus 5, 7. 13 minus 5, 13 minus 5, 8. Then I've only talked about those values which are not being crossed. So you subtract theta from them. Okay. All the element over which only if you see if you see, before I talk about, now see those elements where two line crossed. See those elements over which two line crossed. Like you can see this, you can see this. Over the two line, where the two lines, like where the two line passed, where the two line passed, you can see those elements. So all the element over which the two line passed, all the element over which the two line passed. Okay, what you do, add theta to them, add theta to them. If you add theta to them, if you add theta to them, so 13 plus 5, 18. Okay, and 0 plus 5, this will be 5. Then whichever element over which only one line passed, okay, which is just crossed by one line, do not touch them. So keep it like them. So whatever the value, simply write down. Do not touch them. Okay, once you're done, now what you do again, now we'll try to do allocation. Now again we'll try to do allocation. First row 2 0, don't touch. Second row 2 0, don't touch. Third row 1 0, you can do allocation. Fourth row 1 0, you can do allocation. First column 1 0, you can do allocation. Second column don't touch. Third column don't touch. Fourth column don't touch. First row 1 0 cancel, 1 is there, so you can do allocation. This is your final solution. You can see this. This is your final solution. Every row one element is being allocated, and every column one element is allocated. Then, any doubt, anyone? So if you see your original data, if you compare this allocation on the original data, your original data, if you see your original data, 18, 13, 38, 19, 18, 13, 38, 19, 18, 13, 18, 13, 38, 19, 26, 28, 26, 28, then 19, 26, 19, 26, then 17, 14, 17, 14, then 18, 24, 18, 24, then 11, 26, 11, 26, then 15, 10, then 15, 10. So if you see the allocation, this is allocated, this is allocated, this is allocated, this is allocated. I hope you understood. I can find the total cost. The total cost, that would be 17 plus 13 plus 19 plus 10. So this is 30, 40, 59. I am not wrong. This is 30, 40, 40 plus 20, 60. So this will be 59. This is the optimal cost. Done, everyone. Done, everyone. Any doubt? See, just ask me if you have any doubt.